Alright, so we're gonna do a little bit of a planar motion and differential vector calculus here. So let's start off by doing this problem here. Particle moves in the xy plane so that the time, at any time t is greater than or equal to 0, its coordinates are x equals t cubed plus 4t and y equals t to the fourth plus 2t squared. What is the magnitude of the particle's acceleration vector at t equals 1? So basically we could write this vector's position vector as t cubed plus 4t and comma t to the fourth plus 2t squared, right? So this is its position vector. Now let's write its velocity vector and acceleration vector. So quickly, let's do that. 3t squared plus 4t cubed plus 4t. And that would be our velocity vector. And we could signify that here as of t, right? And then next up, let's find the acceleration vector. So acceleration vector would be something along the lines of 6t, just straight up 6t, no 4 anymore here, 12 here, 12t squared plus 4. So boom, we got our acceleration vector, and now we got to find the magnitude of this at t equals 1. So in this case, we got to find the vector values of the acceleration vector at 1. So there we go, we got to find it at 1. So here it would be 6 comma and then 12t squared, so that'd just be 12 plus 4, 6 comma 16. And now to find the magnitude, we just put these into the Pythagorean theorem. So 6 squared plus 16 squared, it's going to be equal to 256 plus 36, which is going to be 292, right? And we got to simplify this down to whatever the lowest amount is. So we'll say, what should we take out? We'll say 4, maybe 4. So 4, 160, 40, 240, 280. Let's see here, 73. Yeah, so 4. Yeah, that should work. So 4 square root of 4 and then square root of 73. We get 2 square root of 73, and that is what our magnitude is, hopefully. And it is. That is our answer.